All right, we are live. Looks like I've already got one person in here. It's fantastic. We have a special guest today. We'll give everybody a couple minutes to jump in before we get started. So looks like Caesar's in here. What are you up to today? We are just chilling here, getting ready to do some science. It's going to be awesome today. Sun's trying to come in. All right. So while we're waiting for other people to jump in here, I just want to remind everybody on Friday, I sent you an email about this. We have a special guest coming in. It's going to be like a Skype the scientist or Skype with the scientist like we did before in class. I have Dr. Sarah Perry. She's a good friend of mine. She teaches chemistry at the University of Massachusetts. She's going to be coming in and she's going to be talking with us about chemistry, college chemistry to be specific. She's going to be answering your questions about college chemistry and her experience going through college chemistry, kind of like what her work involves. She's very excited to do that because right now she's just like us. She's just sitting at home doing absolutely nothing because her classes got canceled. So, yeah, she's super bored. So while you guys are coming in, if you want to consider this question, don't Google it. No cheating. How many amps of current are in an average lightning bolt? Okay, so no Googling. Just in the chat, type how many amps of current you think are in a lightning bolt. Okay, so I will give candy to the person that's the closest, I guess. I lost my sheet already of people that I owe candy to. But don't worry. I think I remember who it was. So, oh, hey Sarah, how's it going? What are you up to today in your house because we're all on quarantine? How many amps of current are in a lightning bolt? What do you think?
0.
It's not 0. It's more than 0. So for those of you just joining us, I have my daughter here. She is super excited to be joining in today. It was me. 5,000. Caesar. It's pretty close. Good guess. Anybody else? It's not 0. So what's your next best guess?
Is it high?
It's a big number.
Oh.
It's more money than I make in a month.
Oh.
Unless, oh, Sarah says 20,000. That's pretty good.
5,000?
Leela says 10,000. What do you think? 5,000? Caesar already guessed 5,000.
1,000?
It's more than 5,000. What'd you say?
15,000.
15,000? All right. Well, the answer is 30,000.
Wow.
So, Sarah, you were the closest without going over, so I'm going to make a note here. Sarah, I feel like I owe you candy from yesterday, too. Sarah, candy. All right, so we do have a special guest today. For those of you just joining us, it is my daughter, Ivy. Can you stand up and show everybody your shirt that she's got on? Nope, you got to come this way. Here, why don't you stand? Oh, you can see it. She's got her Joliet Central shirt on. She's rocking the cheerleading shirt today. I think it was Giselle that hooked her up with that shirt. So she's very excited. I don't think Giselle's in the live stream with us, but you were pretty sad when they had to cancel that dance thing, right? Yeah, you were really, I know. So, yeah. All right. So Ivy is our resident Roblox expert. She's going to be helping out with a few things. And, yeah. Oh, look, I've even got people from other classes joining us. Hey, Cecilia. How are you doing? Anahi says, hey, Ivy, with 3 Ys. Say hey. Can you?
Hey.
There you go. Okay. So let's keep going here. So if you watch the video, which actually had sound today, I made sure of that. We're going to kind of go through that. And then, because I had some extra time this morning, I shot some video around my house to show you a couple things. So a couple of you were asking for a tour of my house. It's not quite a tour, but I show you a few electric things in the house. So let's get rolling here. So if you recall, these are the 3 things that we talked about previously: voltage, current, and resistance. We also talked about Ohm's law and how it shows the relationship between those 3 things. So we can use the triangle when we use Ohm's law, just like we did with motion. So, yeah, we talked about that yesterday. So moving on today, I want to start with a warm-up problem. You guys are probably all on your laptops right now. Cecilia's just here to annoy me. Okay, that's fine. You're never annoying. okay? Except when you're talking really loud and I'm trying to grade papers. It's always you and Caesar, isn't it? All right, so I've got a laptop charger here, probably similar to the one that you've got. It says find the output resistance of this laptop charger, okay? And I want you to pay close attention to the laptop charger because down here in this green box, you notice it says input and output, right? So it's got two different voltages listed here, and it's got two different currents listed here. So you're probably like, whoa, what's the difference, right? Well, we'll talk about that in a second. Let's go ahead and solve this. So we are finding the resistance. Isn't physics fun?
No.
You're supposed to nod your head, yes. There you go. Okay. So we're trying to find the resistance. So if we cover up the R on our triangle here, and we're going to be left with V over I. So resistance is voltage over current. Cecilia says hi.
Hello.
Okay, so it's voltage over current, V over I. And if you look really close at the charger, it says the voltage is 19.5 and the current is 3.9. So let's go ahead and plug those in, just like that. 19.5 over 3.9. If you want to bust your calculators out, I know you all have them with you right now, and you're just ready to, she did her dad bogus. She did. She did. I was a little disappointed. You're grounded, by the way. You don't have to leave. You're just grounded. No more Roblox today because you did me bogus. All right, so who's got the answer? 19.5 divided by 3.9. First person to chime in with the correct answer, I'm going to put a note on my sticky that you get candy, and hopefully I don't lose this one. I may have lost the one from yesterday, but shh, there's only like 7 of you watching right now, so it's okay. 19.5 divided by 3.9. Anybody? Going once. Going twice. What's the answer? Do it in your head. 19.5 divided by 3.9. 5. Anahi chimed in with the correct answer. Anahi. I owe candy too. All right. Very good. Sarah, you're a little late. I'm sorry. Cecilia, you are not even close. I don't know what happened there. Okay. Who's your physics teacher? I'm going to let them know that they need to maybe go through the math again with you. Or are you just messing with me? All right, let's keep going. So the answer is 5. 5 ohms. You know I'm right. It's not. 19.5 divided by 3.9. Are you sure? Should be 5. Okay, so why do we have a different input and output voltage and current listed on our laptop chargers? Well, that's because we have 2 different types of current. We have alternating current and direct current. Okay, this is not on the test, but it's just something cool to know. You can impress somebody while you're stuck at home on quarantine. So alternating current and direct current. So when the power company sends current to your house, they send it on what's called alternating current. So you've got a wave, it goes up and down like this, right? I don't really want to get into the specifics of this because it's not on the test. I'll definitely link a video so you guys can watch it if you're interested, because I know you guys have nothing else to do right now. So the power company sends the electricity to your house on what's called alternating current. Right? It's a very high voltage, but the devices that you use, like your laptop, can't handle that. So we step it down into what's called direct current, and that little black box in your laptop charger is what does it's what transforms it into a type of electricity that your laptop can use. So it's just something cool to know. Look at this awesome animation. Boom! Now you know. Huh? How cool is that? It took me all morning. Yeah, not so good with the PowerPoints. All right, I have a video for you. Okay, so before we went on break, we talked about the GFI outlets. So if you weren't here that day, because we're going to talk about GFI outlets, and I'm also going to talk about circuit breakers today, I made a quick video of my house and a GFI outlet in my house. So hopefully you can hear the sound. I don't know if this is going to work, but let's try it anyway.
As I mentioned in class the other day,
You hear it?
in your house, next to sinks, you'll have outlets that look like these. These are GFI outlets. That stands
Sean,
for
you're
ground
actually here.
fault
Did you hear the
initiator.
audio?
And it's basically a circuit breaker. So I've got a sink right here, right? So you've got water flowing, and you know that if you put something that's plugged in the water, it's bad news, especially if you're also in the water, like a bathtub. So what these do is they have a protection device inside of it, and when it senses an overload, it'll trip, and you'll hear this little click, like that. And there's also a green light that goes off on most of these. Okay, so that's the circuit tripping. And then if I press the reset button, it will re-enable it
Sorry.
and
I can turn
come
it
back
down.
on.
Uh-oh, I just broke it.
Okay.
Oh, great. I broke the video trying to turn the sound down. Thanks. Well, anyway, you get the idea. All right. So that's a GFI outlet. Okay, Rashawn, I'm not giving you a tour of the whole house. You have to come back each day for a little bit more. All right. So let's talk about circuit breakers because I know you've got one somewhere in your home. So most circuits in your house are 15 or 20 amps. Okay, that's the current that those circuits can handle. Right, and the circuit breaker is there to prevent fire. So if you look in the picture here, I've got a hair dryer, which I definitely use every day. Right, you see me in the bathroom drying my head, right? All right, and then I've got a vacuum cleaner. So if my hair dryer is 15 amps and my vacuum cleaner is 12 amps, that exceeds the either 15 or 20 amp circuit. And if I didn't have a circuit breaker, there would be bad things going on. My house would catch on fire. And, you know, with the coronavirus going on, I got nowhere else to go. All right, I think everything's closed. I can sit maybe in my car. That's a good question. I don't know why. Rashawn, don't be lame. Don't. It's going to be great. I'm doing the best I can with what I got. So why not 25? That's a good question. I don't know. I will definitely find out for you, though. Why not 25? Because you know what? I didn't even think of that. I'm sure there's a good reason, but I will find out for you. So yeah, there are two notes. Yeah, there are some notes that you can fill in. There's some practice problems. We'll get through those in a minute. I just wanted to give you some extra cool stuff. Now, I did another video for you. Went down into my creepy basement, so let me show you that. I'm not going to touch anything. Let me see if I can turn the audio down before I show it so I don't blow anybody's eardrums up. We'll turn it down a little bit. All right, and let's try it. So I'm down in my creepy basement, and I wanted to show you our circuit breaker panel. This is very typical of what you would find in your home. And each one of these little switches is a 20 amp circuit breaker. And the way that they work is when they draw too much current, it'll trip and prevent the circuit from, it'll prevent the electricity from flowing through the circuit. So when you draw too much current, like, you know, if you have a hair dryer and a vacuum cleaner going at the same time. Okay. Now, on mine, I have the furnace. We have two furnaces, and they each have their own circuit breaker here. Okay, if I had both furnaces connected to the same, it would draw too much and it would cause an issue. So many of the rooms have two circuit breakers for the lights and then other things that you might plug in to prevent overloads. Okay, now I should find the one for my son's room and turn the power off. He's currently playing a video game, and he would love it if I turned the power off on him. You also have a master switch up here, and this shuts the electricity off to your entire house. If you ever had to do electrical work, you could certainly shut that off. Or you could isolate a circuit for one of the rooms that you're working on. So say you're swapping out a light switch, or you know, adding an outlet to one of the rooms, you could turn you could turn that individual circuit off rather than shutting off the power to the whole house. So that's a circuit breaker panel. All right. So again, that's you just got to come back each day. I'll give you a little bit more of my house. Okay, I'm not going to tell you where I live though, because I don't want any of you guys showing up, especially because of the coronavirus. Okay. All right. So let's move on here. So I have a simulation. I bet half of you just groaned right now. Okay. I know Rashawn groaned, right? So I have a simulation I'm going to show you. It's not as exciting as the ones we've done before, but it's still pretty cool. So this is Ohm's law right here. V equals I times R. And what it does is it allows you to manipulate things, and it shows how things are affected. So if you're looking here at the current is 9 milliamps. So if I were to double the current to 9, it makes really cool sounds. Just wait for it. Whoa, how cool is that? Notice the current doubled. All right, so let me bring it back down. Again, listen for the sound. It's so cool. Tell me that's not the coolest sound ever. You're going to be playing with this all day. They said you look like you're having fun. Are you?
No.
Okay, I may have promised her extra screen time if she joined us. You want to show me your pictures in a minute?
Sure.
All right, well, we'll get to the end, and then she has some pictures she wants to show you guys. Okay? Caesar, again, I'm going to write you up, man. Where are my referral slips? just going to write it out on the sticky pad right here. Okay. I already had to write you up for being loud this morning. I had to write you a referral for being loud. Detention. Yeah. All right. So anyway, you can play around with this if you want, but it's a cool visual because you can see how things change. So if you notice, the voltage here is 4.5. So if I double the resistance to 1,000, watch what happens to the current. So the current went down to balance it out. Okay, there you go. That's the best I can do with PhET. I didn't really have a very exciting simulation here. So anyway, let's keep going. I have some problems, okay, and these are definitely ones that I would know how to do because we have some variables that we can manipulate: voltage, current, resistance, and you need to know how they affect each other. Okay, so here's the problem: if the current remains the same but the resistance is doubled, how does that affect the voltage? Okay, so looking at our triangle, if we're trying to find the voltage, we're trying to find the effect on voltage. Let's use the equation V equals I times R. Okay, so here's our regular equation. Now you know how my students feel. So if we are going to double the resistance, how would that affect the voltage? So if we represent doubling the voltage mathematically, that would be 2 times R, just like that. All right, and then I've told you guys, whatever we do to one side of the equation, we have to do to the other. So look at that. I got to point this way, this way. Yeah, so whatever I do to one side of the equation, I have to do to the other. So if I double the resistance, I get double the voltage. Now, think about that. I told you voltage is like the pressure. Okay, so if you are resisting something, you have to apply a little bit more pressure to get stuff to flow through. Okay, so water in a pipe is a really good analogy for electricity flowing through a circuit. All right, let's look at another example. So yes, voltage is doubled, and then here's the next one. If the voltage remains constant, oh, I lost a viewer. Try to make this more exciting. My daughter has some awesome pictures she wants to show you, so don't leave the stream because you're going to miss out on that. So if the voltage remains constant but the current is doubled, how does that affect the resistance? All right, so if we are looking at resistance, how it affects resistance, we want to set everything equal to R. So if we cover up R on our triangle here, we get voltage over current, V over I. All right, now this is a little tricky. If we are doubling the current, we're doubling the current. Current is in the denominator. So let's put our 2 in front of the current. So if we double the current, 2 goes in the denominator. Now since the 2 is in the denominator on the right side, 2 has to be in the denominator on the left side. Like that. Okay. So this one's a little tricky. Just whenever it tells you you're doubling something or tripling something, just put that number right in front of what you're working with. Okay, so 2 goes in the denominator on the right side, 2 goes in the denominator on the left side. So in this case, resistance is halved. Okay, so again, thinking about water flowing through a pipe, right? If there's more flow going through, the resistance is going to be less. Okay, if it's able to flow a little bit faster, you're going to have a little bit less resistance. That's what it means, essentially. I got one more for you. If the resistance remains constant, but the voltage is halved, how does that affect current? Okay, so if the resistance remains constant, but the voltage is halved, how does that affect current? Okay, so I'll let you guys play around with this one for a minute. Just cover up the current, which is I. Cover up the I, and then put the divide voltage by 2, all right, and see what you come up with. All right, so I'll give you a minute to do that. And while you're doing that, I'm going to thumb wrestle my daughter here. All right, ready? 1, 2, 3, 4. I declare a thumb war. 5, 6, 7, 8. Try to keep your thumb straight. What is Max doing over there? Got it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I win. Best dad ever. Current is halved. Caesar, are you looking at the notes? Caesar, I know you got this. I'm going to put your name down. Caesar gets candy. Caesar gets candy. Okay, so let's set this up. So current is equal to voltage over resistance, just like that. 2 goes in the denominator because we are doubling the, voltage is halved, so that 2 goes in the denominator because we are halving voltage. Okay, if you're halving something, it's the same as dividing by 2. 2 is in the denominator on the right side, so 2 has to be in the denominator on the left side. Okay, awesome. Caesar, you are correct. Oh my God, today is Caesar's birthday? Should we sing Caesar happy birthday? All right, you know what? We made cake yesterday. why don't you go get a piece of cake? Can you go get a piece of cake? Here, you know what? How about this? I'm going to go get a piece of cake and a birthday candle. Can you sit here and talk to them?
Okay.
You know what? Why don't you use this time to show them your pictures? Okay? Here you go.
Hello. Okay, so I don't know if you can read it, but it says physics is super. It's Baby Yoda, and it says science is awesome. And then yeah, follow me in the lesson. Yeah, so okay. Hello. No, he did not. And then I have some more since I have time. Let's do this one. If you're not paying attention, you're gonna need some popcorn. I don't think.
Okay, what happened here? Anybody say anything bad? Like Caesar? Caesar's a good kid. All right, so is it really Caesar's birthday? I don't know. I'm not going to check because this is so cool. So I'm going to go ahead and like this, and we are all going to sing happy birthday. You have to type it in the chat to Caesar. Here we go. Look at this actual birthday cake. How cool is that? Ready? On three. 1, 2, 3. Happy birthday to you. Happy birthday to you. Happy birthday, dear Caesar. Happy birthday to you. Blow it out. All right, Caesar, I know your home address. I'm going to go ahead and mail this to you. I'm just kidding. It could have the coronavirus. Can you take care of that?
Thank you.
All right, good work. Okay, so that's pretty much what I had for physics today. What other questions do you have? I know Caesar asked a question, why not 25? Why aren't those circuit breakers go up to 25? So I will find that out for you. So what other questions do you guys have for me? Anything? Why he run like that? I don't know if you caught it, but I'm not wearing dress pants. I'm actually wearing jeans today. Okay, I told you that I would wear a tie. Yesterday, everybody was really upset that I didn't have a tie on. It upset the balance of the universe, so I put a tie on today. But I am not wearing dress pants. Shh, don't tell anybody. I have jeans on today. Right? Okay. Anything else you guys want to know about electricity? Tomorrow, we're going to do a little bit more practice with Ohm's Law. And then Friday we have a quiz. Easy quiz. Easy quiz. Okay? Just kind of reviewing what we've got. And then spring break, right? We're all going to go to the beaches. Oh, coronavirus. Yeah, so that kind of stinks. I don't know what I'm doing for spring break. Yep. How's the cake? Tell Caesar how the cake is.
Good.
It's good. I actually baked the cake, okay? I personally baked the cake yesterday in between doing grading and stuff. So, yeah. So what other questions do you guys have? What are we watching on Netflix right now? Anything? If anybody is a Star Trek fan, got a new episode coming out tonight. I'm super stoked. I'm going to be up late watching that and doing stuff, doing grading. I'm definitely grading. I've been grading like this whole time, right? You see me grade?
Mm-hmm.
Yep. Okay, definitely grading. I'll get all those grades in. Don't you worry. All right. So what else? Nothing. Who's watching a cool show? Come on. I'm sure you guys are doing something. I know you're not all doing school stuff like all day. I do bake and cook. Okay. Actually, chemistry, stoichiometry, which you'll get into next year if you're taking chemistry with me. It's totally baking. Okay. I was busting out chemistry last night. Cash money. Hey, you missed it. We sang Caesar happy birthday. It's his birthday today. And I have my daughter Ivy here. Say hi.
Hello.
Do you want to do the Renegade? Do you know the Renegade?
Not really.
I don't know it either. She was trying to teach me. All right. You what?
I only know one that's not like that.
You're capping.
What?
You're capping. You know lots of dances. She's like a star. Denasia, what's going on? We'll do chemistry in a couple minutes here. So, any questions about physics, not chemistry yet, not yet. Any other questions about electricity? You guys have any trouble with the Ohm's law stuff? I know it's honestly, it's just pretty straightforward. You just plug in. But if you want me to work through some more problems, I can. Do you have any questions about Roblox? My daughter is here to answer your questions. Also want to remind you that Friday, we have our special guest coming in, Dr. Sarah Perry, chemistry professor at the University of Massachusetts, will be joining us via Skype on this live stream to chat with you guys and talk to you about college chemistry, which is awesome. I actually had this planned for this week, but unfortunately, coronavirus. So she's stuck at home too and looking for stuff to do, so she's going to jump in and Skype with us on Friday. So that will be awesome. Yep. How's Roblox going?
Good.
Good? Okay. Cecilia, you need help with your advisory homework, okay? What is your advisory homework? Because usually it's just you and Caesar talking very loud in the back of the room, okay? And then you're always trying to leave your softball stuff. Okay, so doubling the thing on the practice, like if you double something, what happens to the other thing? Okay, so I know you jumped in a little bit later, but I do have this. I'll post a link. Let me see if I can post this link in the chat here. So this is a good simulation that you can play around with. This gives a really good visual of what's going on. So like if you have voltage, so if I make it really easy. Let's make it 1. And the sound effects in this are great. So if my voltage is 1, my current is 2. All right. Milliamps aren't quite the same as amps. All right. It's just a different version of it. So if I double my voltage, watch what happens to the current here. My current doubles. Okay. If I double my resistance, watch what happens to the current. Okay. So you can play around with it there. Hey, Grace, how's it going? We'll get to chemistry in a couple minutes here. So if you're not quite understanding how it works mathematically, you can play around with that simulation. I'll try to work some more of that practice in tomorrow, because that is probably the hardest to understand, like if you're doubling, tripling, halving stuff, how that works. So let me work some extra practice in tomorrow. I was trying to think how we might be able to do like a Kahoot or something while we're streaming. I'm not sure how that would work exactly because there's a little bit of a delay with the stream, but so I was right. Yes. I don't know what she's saying yes to. Okay. But yeah, it's a good thing to play around with. It gives you a good visual. You can see how because the letters will actually get bigger or smaller depending on if they're going up and down. You're doing a good job. Okay. So if you guys don't have any other physics questions, I'm going to get ready to switch over to chemistry. I hope you guys are all having a great time on your break. Everybody has everything they need to be safe. I know there's a lot of crazy stuff going on in the news right now. It's probably best if you just don't watch it, okay? There aren't zombies like popping out of the ground and coming after people, so I'm sure it'll all blow over eventually. So just focus on your school, do that stuff, watch your Netflix, enjoy the time off, sleep in. Don't forget to do your attendance, though, between 9 and 11:30. And, yeah, that's about all I got. Do you have any words of wisdom for everybody?
No idea what that means.
Words of wisdom? Let me see if I can turn my mic up. I think it's kind of low. Is that any better? There we go. That's better. Okay, do you have any words of wisdom for anybody?
No idea what that means.
Just like any general advice?
Do not watch the news.
There you go. Don't watch the news. And Roblox is going okay?
Yes, it's getting hacked.
It's getting hacked? Who's hacking it? Is it Caesar? It's probably Caesar. Thinks it's his birthday. Did you eat that cake already?
Maybe.
Wow, that's awesome. Okay, well, if you guys don't have any other questions about physics, I'm going to go ahead and start going through the chemistry stuff. You're welcome to stick around and watch if you'd like. Otherwise, I'll be back on tomorrow. And I just want to remind you that on Friday, we have our special guest, Dr. Perry, coming in to talk with us about college chemistry. She's adorable, Denasia says.
Me?
Yeah. Yes, you are adorable.
Thank you.
Okay, so let's get into chemistry now. Okay, so if you're just joining us, I sent an email out about a cool thing we have going on Friday. we were going to Skype with Dr. Perry if we were physically in school. I've had this set up for some time, but obviously the coronavirus came along and messed everything up. So she's going to be doing it online instead. She's going to be jumping in and talking with us via Skype. So I emailed you a link that you can click on that has a Microsoft form. You can put your questions in there, kind of like what we did if you came to the Skype of Scientists with my physics classes. Any questions you have about chemistry, what college chemistry is like, if you're considering a career in college chemistry, like what classes you would need to take, what her experience is like. She told me that her type of chemistry is the best because she gets to make things. And I told her how you guys are always asking me to make drugs. She thought that was hilarious. No, not really drugs. I would never do that. I'm not Walter White. I do have the goatee, though. So she said she's awesome because she makes stuff. She's the kind of chemist that makes stuff. So she's really excited about that. So for those of you that are joining me right now for chemistry, I want you to bust out the Google, and I want you to find the specific heat of milk. First one to chime in with the answer will get candy if and when we go back to school. All right, I have a list going for today. Hopefully not going to lose this sticky like I did yesterday. What? Oh, Grace is getting McDonald's. Grace, is it really worth risking your life to get McDonald's? McDonald's is really not a good choice. Right? A lot of sodium. This food is bussin'. What does that mean?
I don't know.
I don't know either. I know what cappin' means, right?
I know.
It's like when you tell me something that's not true, I say you cappin'.
I just say you lying.
Yeah, well, cappin' sounds better. Okay. 3.93 times 10 to the third joules. Is that correct? It is close enough. Okay. If you look online, there's actually a couple different versions depending on if it's skimmed milk or whole milk. Okay. So we've been talking about specific heat. We talked a little bit about calorimetry. We went through the lab. So specific heat is you do work at McDonald's. I'm sorry. I didn't, like, their food's good. Don't get me wrong. Their food is good, but I don't know. Is it really worth getting the coronavirus is the point I'm trying to make. All right. So 3.97 is the specific heat of milk. And that specific heat is unique to everything. So everything has its own specific heat. All right. Like plastic has its own specific heat. Metal has its own specific heat. Each type of metal has its own specific heat. You probably have your own specific heat. All right. And that specific heat, remember, is how much energy it takes to increase 1 gram of something by 1 degree Celsius. Okay, so everything has its own different specific heat. All right, yeah, it was Caesar's birthday in my physics group, and so we got out some birthday cake and sang for him. If you missed that, I will save the live stream and you can go on later and watch it. All right, so we do have a special guest today. This is my daughter, Ivy. She is a Roblox expert, and she's going to be joining us today to help out. And she's got some pictures that she drew that she wants to show you guys if we have some time at the end, which I'm sure we will. So all we're going to do today is go through the background information on the lab. That's what I asked you to do today. So if you haven't done it, which I'm guessing most of you have done it, maybe. If you haven't, that's okay, because I'm going to go through it. As I said, it's probably in your notes. I just want to review it. So if you are working through the lab, I told you yesterday that you need to cite things. You can just cite this video if you want, because all the information is going to be in it for today. All right, so I told you that you're going to be working on the background info. Thank you. Thank you. You'll be working on the background information, and there were 5 things that you needed to look up. Okay, so Denasia, you already did it. That's great. If you already did it, just maybe check and make sure that what you've got matches up with what I've got. If you want to add any other information, although it's pretty straightforward. So let's talk about specific heat. We kind of already did that with the milk. Okay, but specific heat is the amount of energy it takes in the form of heat to raise 1 gram of something by 1 degree Celsius. Right? And if you look at the table here, every one of these metals has a different specific heat value. Are you having fun yet? You should see the kids in chemistry. They are like on the edge of their seats, so excited about it. They're just eating everything up that I say. They just love it. Are you having fun?
Should I tell the truth?
Yeah, you don't want to lie. Are you having fun?
No.
Okay, well, just when you get to high school, it's a little bit more exciting because you understand things that are going on. Okay? All right, so that's specific heat. So I'll make sure that this is saved on my YouTube channel, so if I'm going too fast and you miss something, you can go back later and you can pull it up. Okay, so there's specific heat. Should be in your notes. All right, where is this located? This is in the lab. The lab itself has all of the questions, but I'm going through the background information. I told you in the instructions for today to find the information online, so whether you found it or not, I'm just going to go through it. All right, and Grace asked the question, what does the lab do? Sorry if I'm supposed to know this. Okay, that's a good question. I don't know. I'm trying to break the lab up into small chunks so that it's manageable. Janasia says, girl, don't let him lie to you. She's saying that chemistry is actually way more exciting than I'm trying to tell you. She says that's all cap. That means I'm lying. All right, anyway. So I don't know when the lab's going to be due, okay? I'm trying to break it up into small chunks because I realize that if I just gave it all to you guys at once, nobody's going to do anything. So I'm trying to give it to you in small chunks, and I'm trying to go through how to do it each day so it's manageable, because I saw all of the groans and eye rolls that I got when I said we're doing a lab on that last day of class. Okay, so the next point that we need to go over is what does it mean if a substance has high or low specific heat in terms of how quickly it will heat up, okay? So looking at those specific heat values, the lower the specific heat value, the less energy it takes to heat it up. Okay, so if you have a lower specific heat value, like lead's really small here. So lead specific heat value is very low, so it's going to heat up faster. Okay, hey Daisy, how's it going? We're talking about chemistry right now. Physics is at 1. But you're still welcome to jump in and listen and learn some chemistry. So again, lower specific heat value means that it's going to heat up faster. Okay, so that's pretty much all you need for that one right there. Again, if I'm going too fast, stop me. If you have questions, just type them in the chat. I don't know where Saida is today. Hopefully she's okay. I know that she's so into physics, and she's probably really disappointed that she's not here. All right, next. How can knowing the specific heat help you identify an unknown metal? So I told you that every single metal has its own specific heat. Well, Denasia, tell Saida to jump in. I don't know why she's not here. She's being a slacker today. She's probably watching YouTube. Or not YouTube, Netflix. Okay, so how does knowing the specific heat help you identify an unknown metal? So I told you that everything has its own unique specific heat. So looking at the table here, if you were able to figure out its specific heat, you can just look up and see which one it is. It does get to be a little tricky. If you look at the table here, look at the values for copper and zinc. So copper and zinc, if you look at both of those are both really close. 3.85 and 3.88. You'd have to be very, 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 very accurate. Get the poll. What are you talking about? We be ready to beat him up. What?
I don't know.
Oh, they're going to beat me up. I don't have the poll. I have a baseball bat at home, but I don't think I need it yet. The kids have been still okay. Like, you and your brother haven't been very bad, right? Yeah, okay. All right. So if you know the specific heat value, you can just go to a table of known specific heats, look them up, and figure out what you've got. Okay? So that is that. And then the next question is, what is a calorimeter? Now this one might be a little harder because I kind of showed you really quick in class. So calorimeter is a well-sealed container, well-insulated, and it's got a thermometer. So we used a styrofoam calorimeter. I showed you a coffee cup on the last day that we were there. You can use a coffee cup, styrofoam coffee cup as a calorimeter, that works. But really fancy calorimeters are very well insulated, like those, what are those called? Those really fancy coolers. I can't think of the name of it right now. Is it Yeti? Oh, see, there is a good point to have you here. Okay, Yeti. Yeah, the Yeti coolers. Like, they can keep things frozen for, like, forever. Those are very well insulated. If Yeti made a calorimeter, I'm sure it would be awesome. Okay, so it's very well insulated. So when we put the metal in, all of the heat that's exchanged between the water and the metal is kept within that container, right? So we use the thermometer to measure the change in temperature of the water. So if you're looking at the picture here, This is very similar to what I used. I didn't have a stirrer in there though, but it's got water. So we drop the metal into the calorimeter, and the heat from the metal transferred to the water, which I'll kind of get into in the next slide here. But that's basically what happened. And we measured the difference in temperature of the water. Okay, and we can use that temperature difference to then solve for the specific heat of our metal. All right. You can also use calorimeters when you're doing chemical reactions, when you get to how much heat is released in a chemical reaction, but I don't think we're going to be doing that this unit. Is it the same way for a large cooler? I don't really understand your question. Do you understand his question?
Maybe, I don't know. Maybe
You
like a
chimed
bigger-
in with the Yeti thing. You are like off camera. You got to scoot over a little bit more. Okay, there you go. All right, do you want to show everybody your shirt?
Oh.
It's pretty epic. Look at this. She is sporting the Joliet Central cheerleading shirt today, and I'm wearing a tie because a lot of people were upset yesterday that I didn't have a tie on. So, all right. Well, that is a calorimeter. Any questions on that? Well, you can show them your pictures when we're all done. Okay? We're only 11 minutes into chemistry here. Okay. So the last thing I need to talk about, last question that you had to answer for the background information. Hey, Saida. Say hi, Saida.
Hello.
You're supposed to say hi, Saida.
Hi, Saida.
There you go. Saida's here. All right. Now let's talk about the first law of thermodynamics and how it applies to calorimetry. So, first law of thermodynamics is energy cannot be created or destroyed, only transferred. It's like money. Okay, I can't print my own money. I'm not supposed to rip up money because I think you go to jail for that. So you can only transfer it. So like I could give my daughter $10. I'm transferring the money back and forth, and then she'll give me $10 when she needs more screen time or something. We're just transferring the money back and forth. All right. So money kind of works the same way. Now in calorimetry, that heat energy is conserved. So if you look at the picture here, it took me all morning to make this picture. You've got water, which is at the bottom of our calorimeter, and we drop in our piece of metal. So the heat energy from that metal gets transferred to the water, and the heat energy from the metal lowers as it's transferred to the water, and the heat energy from the water goes up because it's picking up some of that heat energy from the metal, okay, until they reach that point of equilibrium where they're the same. Okay, that's pretty much it. So the way that it applies to calorimetry is we're just transferring that energy, and we can measure that transfer with our thermometer. Seda says, when is the simulation for the light bulb due? Because I haven't started on that nor the work for today. Upside down smiley face. Can you do that? Upside down smiley face? Yeah, it's not so easy. Yeah, you gotta like stand up and like go upside down. No, don't hurt yourself. We can't go to the hospital right now. There's too many people there. Corona. I don't know which simulation you're talking about. I just asked you to work through some practice problems for today. Like it should have taken you 3 seconds. We actually went through the practice problems for today on the stream. So Saida, if you go, once I save this on YouTube, you can actually go backwards and you can see how those work. Yeti are pretty awesome. I can't afford a Yeti. I'm in trouble because my wife is not working right now because her dental practice had to shut down. So I am the sole breadwinner right now on my teacher salary. So we're going to have to eat ramen noodles for a while. And canned ham, yeah. I went to Jewel to go get meat, and they were all out of meat. So I bought cans of Spam.
Spamming in chat.
Yeah, you're really excited to eat Spam, aren't you?
No, I'm not.
No, you're not. All right. Ava, it's okay. I'm glad you can make it. So the last, let's see here. So for today, I just asked you to work through the background. We went through all of the different points on the background. So all I need you to do is basically summarize that in a paragraph, okay? And I asked you to put it at the end of your lab document. So if I open up OneNote here really quick, let me go to chemistry. So in the lab document itself, what I want you to do is take the background information, and I asked you to put it at the very end. Okay, so after that last page down here, just type it in there, just in like a paragraph. That's it. If you want to type your lab up in Word or OneNote, not OneNote, Word or Google Docs, you can, just like we did with the previous lab. But I want to be able to kind of check you as you go along and do stuff and give you feedback. So if you're doing it in Word or OneNote, that's fine. If you could just maybe paste in the background information that you come up with for today and paste it in at the very end, I can take a look at it. That would be great. Or you could just type it all in OneNote. Either way is fine. Okay? Any questions about the lab?
No.
No?
Well,
Okay.
actually, yes.
I'm on OneNote and I see no assignments. Saida, you're in the chemistry. It's chemistry now. 1:30 to 2 is chemistry. You missed the physics bus. I'm sorry. Your assignment is in OneNote under notes. It's under notes today. The practice problems were after the notes. Yeah, come on, Saida, pay attention. I have to write her up. Okay, so that's pretty much all I had for chemistry today. Tomorrow you're going to be getting some lab data. I was actually just finishing that. Didn't have enough time to get it together before we started today, but I'm going to be giving you lab data tomorrow so that you can go through and do the calculations. I guess I could talk about that really quick. And then I will turn it over to my daughter to show you some pictures that she's so anxious to show you guys. So for the lab data, you get a little preview of what we're doing tomorrow. For the lab data, I'm going to give you all of the data. Everything you need is going to be in a document. Every single person is going to have their own unique data set. So from the data that I give you, you are going to go into Grace, you should have gotten a lab. The lab should be under homework. It is labeled calorimetry lab. It should be under your homework tab. So anyway, the data that I give you, you're just going to transfer to the data table right here and then do the calculations. The calculations that you have to do are identical to what we've done over the last couple days. Tomorrow during the live stream, I'm going to go through sample calculations with my own unique data set. So you guys, if you don't know how to do the calculations, tomorrow if you jump in, I'll do them with you. Okay? So again, I'm trying to break this into small, manageable chunks, so it's not very overwhelming trying to do this. I know you guys have a lot to do from other classes, and it definitely shows that you have to catch up on, so I get that. Denasia, your stomach hurts. I'm sorry. Is stomach pain a sign of the coronavirus?
I don't know, because I have a stomach ache. But I think
You have a stomach ache? You have a dry cough?
I think it's from the cake.
Oh, it's from the cake. Yeah, I did just give her a slice of cake because I'm a bad parent. Okay, so what questions do you have on the lab? Any questions about the background information? Anything I can clarify? Grace, did you find the lab in OneNote? Wait, Denasia, they're making you work tomorrow? That's terrible. I would not trust anybody right now. You should just drop out. Don't drop out. You dropping out of work or dropping out of chemistry? Who's Panda Express?
That's what I was trying to say.
I don't know.
I have corona.
Corona?
Ah.
I'm going to drop out and work at a club. Oh, that's great.
No, that's not a good habit.
So, anybody that's in chemistry, can you double check to make sure that the lab's actually there? It's showing up as being there on my end, but I want to make sure that you guys have it before I move on. Nobody said anything to me, so I'm assuming it's there. Oh, you can show your pictures in a minute. Yeah, so I'm guessing that means it's there. Grace, were you able to find it? Yes, I found the lab. Cool. All right. So the background information, if you go back, if you came in late, if you kind of go back through the video once I save it, I answered all the questions, and you can cite this video when you get to that point. Just summarize it in like a paragraph and stick it at the end of the lab document. Okay? And then tomorrow you're doing the calculations. I'll be sending everybody out I'll be sending everybody out data to do the lab with tomorrow. So that's it. What other questions do you guys have for me? What Netflix shows are you watching?
Oh, I saw one that's like, I forgot what it's called though. On
What?
the block, it said someone said.
Is Henry Danger over?
What?
Henry Danger? Is that the show you watch? Henry Danger?
Yeah.
Yeah?
Well, there's one more video. One more.
Oh, there's one more. Okay, cool. Do you want to show everybody your pictures? Because I don't see any questions
I've
yet.
been waiting all time.
Oh, okay. You want to show everybody your pictures? Do you want the mic?
Yes.
You do? Okay, I'm gonna pass it over to my daughter for a second. Caesar wants me to pass it over. All right, here you go.
It's a little big.
Here you go.
Okay.
You gotta stand up and you gotta hold it up so you can see.
Okay. So, if you I got some popcorn.
gotta hold it still. There you go. She made popcorn.
Mm. Yeah, you gotta follow along.
Gotta follow along. Gotta hold it like this. What is that? TikTok?
Oh.
Grace, I'll get to your question in a second. What is that? Baby Yoda?
Baby Yoda.
Nice. And who's that? Sonic?
And then I got one more.
Oh, one more. One more.
Okay, fine.
Oh, for St. Patrick's Day? Oh, look at that. That's pretty cool.
I know my dad's bald.
Yeah, okay, great. Can I have it back? To do my job. All right. So, Grace, to answer your question, yes, you can put it in your own document. However, I'd still like to see the background information. So, if you're going to do the printout like you did last time with the lab, that's fine at the very end. But if you could just maybe copy the one paragraph for today for the background information, just paste it in at the very end, that'd be great. I just want to make sure that you're doing it and then to give you feedback on stuff, okay? I want to make sure that everybody gets an A on this. So I just want to kind of see your progress as you go along. Did that answer your question?
Why are you bald?
Mr. Soren, why are you bald? Saida. Should get TikTok. Do you want to show them the Renegade?
I do not know it. I only know like one that kind of.
You're capping. You know the Renegade. You were showing. You're trying to do it yesterday. Yeah. Show them the Renegade.
I don't like.
Grace says Yoda and Sonic are so good.
Oh,
They can't
thank
see you. You're sitting down. You got to stand up to do the
Well,
Renegade.
one, like,
All right, let's do it. Right? Isn't it like this? How do you do it? Wait, I gotta back up. Right here. You gotta back up a little bit more. Right here. How do we do the Renegade?
I don't know.
Come on, you know how to do the Renegade.
This is what I'm gonna guess.
Why my grade ain't changed yet? Because I haven't put grades in yet. I'm doing the best I can, Saida.
Yeah, I know this one.
No, that was Denasia. Sorry. So how do we do the Renegade?
No, this is one. This is I know a different one.
Is that right? They'll tell you if you're doing it wrong. Okay? Where's Jemiah? Jemiah and Ashanti are all over the Renegade. Instead of doing my class, they're always doing the Renegade and back. All right, so how do we do this? Is that right? We need the music.
I think it's snap.
I
can't get
how
the
do I
music.
get the music? Whip, nay. No,
Let's
we'll
do
get the
it.
music tomorrow. Maybe tomorrow. All right. I'm trying to do my job here right now. Super unprofessional. Okay. We watching Frozen 2. Oh, I haven't seen. We should watch Frozen 2 today.
I don't like it.
You don't like Frozen 2? Why
I
not?
don't like Frozen. I'm
That's a
frozen when I
lie.
watch it. Okay, if
You're
you're
capping.
watching Frozen,
She's
you're
capping.
gonna get very cold.
Grace says Frozen 2 is so good.
We watching Frozen too.
Yeah. Let's watch Frozen 2 when we're done with this, because I.
I'm gonna
Oh
get so
no!
cold.
Actually, nope. I'm not watching Frozen because I'm working. Okay. If anybody asks, I'm working.
Yeah, she's working.
I'm doing my job. Okay. Until 3:15.
I watched it yesterday.
Right.
Here she
I still have an hour and
Thank
15
you,
minutes.
Ava.
Okay. So you guys don't have any other chemistry questions? I don't know what else you want to see. We got 7 minutes, and I'm gonna stick around for. Denasia, it'll be okay. I'm gonna grade. I got an hour to grade after I'm done live streaming. Okay, I'll get it in there for you. What else do you guys want to know? Do you have any questions for my daughter?
Yeah.
She's a Roblox expert. She knows a lot about Roblox. Why am I dressed up? Yesterday I was not wearing a tie, and everybody got really upset. So I put a tie on today. But if it makes you feel any better, look at this. I'm wearing jeans underneath. Ha ha. I was gonna wear pajama pants, but I thought that would be unprofessional. Yeah. Any questions for us? Any other questions? We got 6 minutes. Ask us anything. It's like Reddit. Ask me anything. Imagine being bald. How would you feel if you were bald? All right, Grace. Be safe at McDonald's. All right. Don't touch anybody. Do the.
Okay.
Don't
she
even
wants
don't
to know
even
my
fist bump.
TikTok.
You are not giving your TikTok to Ava. Not giving your TikTok to Ava because that would be bad. Okay. Yeah, she's always she's a good kid, but I still wouldn't trust her with your TikTok. What do you have on your TikTok?
dances
Dances.
that I made up.
Oh, you're painting your house. That's great.
Oh, we can do that to this.
What?
We're gonna paint the office.
We're gonna paint the wall. What color should we paint the
Yeah,
wall?
what color?
You know what? I need a green screen, so I can have like my classroom behind me.
It's gonna be lime green.
Yeah, I need a green screen so I can put my. I took a picture of the classroom before I left on Monday, so
Somebody subscribe.
it'd be cool if I could green screen it. Ava, I'm sorry, I can't give you that.
What?
Call 911. What are you talking about? Is that a song? Call 911.
I don't know.
Let me see if I can make that play. I gotta find the Renegade.
Oh yeah, I know what it's called. Lottery.
What?
Play lottery. That's the Renegade.
Lottery.
That's the Renegade one.
Hold on, let me see if I can get it.
It's Renegade.
Do you know the dance?
Yeah, I don't.
Okay, so Panda Express, what do you need help with?
Panda Express.
Yeah, where's the
Okay,
Renegade?
I want to get some food. Yeah, I want some Panda Express.
Is it Renegade? Is it the name of the
It's called
song?
lottery.
Lottery? Are there bad words in the song?
No, I don't think so. Maybe. I think though. Maybe.
You don't sound too sure of yourself. Lottery?
Maybe. You guys heard the
Let's see if
H
I can
word.
find this song. Oh, that's fantastic. I thought you said I was your favorite.
Lottery.
Ava, I don't think I ever said that.
Renegade. Oh, I guess you can look up Renegade.
I'm pretty sure there's bad words in this. So, seriously though, Panda Express, what do you have questions on? Is this the song right here?
No, it's not.
It's Renegades. Everything. Like, can you
It's
be a little more
Lottery
specific?
Renegade.
Is it the lab itself?
Lottery Renegade.
Okay, well, hold on. Let me
have
answer this
another one
legitimate
as well.
chemistry question first.
Sunday's best.
I'm not giving you my daughter's TikTok. Panda, what can I help you with? Is it the
Everything.
what you're supposed to do in the lab? Because all I asked you to do was to look up the background information. So far, all you've had to do was watch the video, which you just sit and watch the video, and then the background information. If you didn't understand the background information, I went over that earlier in this video. So when I post it on YouTube, you can maybe just go back in the video and pull it up there. Google also has all the answers, and your notes should also have everything. Panda, I have no idea who you are. So are
Me
you in
neither.
chemistry or physics?
Or Panda Express.
I don't like Panda Express. I'm a
I
vegetarian.
want some food.
And
Now I'm hungry.
yeah, we can't have Panda Express because of the coronavirus right now.
I didn't eat onions.
Panda, what
I ate
questions do you
onions.
have? Got a couple more minutes left.
Solving it. Michael things.
Wait, get Michael in here. I want to talk to him.
Oh, I want to talk to Max. Let's get Max in here.
Are you talking about the MC delta T? Chem, MC delta T. So we haven't done. Okay, so you're talking about the homework from like yesterday, right? So like, let me see if I can pull it up here. Like this right here.
Coffee cup.
I don't know who you are.
She's chemistry.
Are these? Is this
It's
the
chemistry.
stuff you had questions on?
It's chemistry.
Because I'm happy to go through one of these if you'd like.
It's chemistry.
Yeah, I see that. Yes.
How rude.
All right. So the coffee cup one or the one from the day before? Nope.
No. Yes. No. Yes. No.
Is the one from the day before? All right. You got to be a little more specific than no. Yes.
No. Yes. No. Yes.
So we had this. Whoa.
Whoa.
You don't know what that means.
Yes, I do.
All right. This. Bye, Denasia. I'll see you later. Panda, is this what you're having trouble with?
I know I am.
You don't need to know this yet. Any. Okay. Let's do one of these. So bear with me for just a minute. I'm going to pull up my chemistry stuff. Great. Michael's going to get the last couple minutes. Let me pull this up here. So we're looking at
We have 1 minute left.
That's alright, I can stick around for a minute. Alright, Denise, you'll see you tomorrow. Alright. So let's go through one of these. Let's look at, honestly, these are all the same. So let's just go ahead and do the first one here. So let me pull out, hold your drawings here.
Let's just give my next thing.
Nice. Don't look at the screen.
What's screen?
Yeah, it's fine.
Oh, that?
Yeah, it's fine.
My top? What?
Alright, let me drop this into chemistry.
Can I write something?
No. bear with me for just a second. I'm going to put this in so we can go through one of these problems. Yep, everything, Daniel, the lab is in OneNote. All right, let's see here. All right, let me switch this up. All right, so let's look at the first one here. So it says that you have a 15-gram sample of metal at 75 degrees Celsius. It's added to 150 grams of water at 15 degrees Celsius. The contents come to a final temperature of 18.3 degrees Celsius. That's the metal and the water. That's the equilibrium temperature. The specific heat of water is 4.18. Calculate the specific heat capacity of the metal. All right, so for starters, there's a lot of information in these, and I get that's probably the hardest part. There is a lot of information in these questions, and you kind of have to sort it. So I'm going to start by making I'm going to start to put the information into like two categories, either for the metal or the water. So for the metal, remember our equation is this one up here, our MC delta T. So for the metal, the mass of the water is 15.0 grams. And we don't know the specific heat. That's what we're solving for. Michael is slow. I'm sure he'll jump in at some point, or maybe I'll see him tomorrow. Okay, the final temperature of the metal, the equilibrium temperature, is this right here. So the final temperature is both the final temperature of the water and the final temperature of the metal. So it is 18.3. And the starting temperature of the metal is, what is that? Reindeer poo? That's fantastic. All right, the metal starts at 75 degrees Celsius. So to find our delta T, our change in temperature, it's going to be the final temperature minus the initial temperature. So the final temperature of our metal is 18.3. And our starting temperature is 75 degrees. So when you subtract those, you get 56.7. What are you doing with the reindeer poo? You're a bad kid. I'm going to ground you. All right, so let's do the water next. So you have an initial temperature. So if you watch the lab video, the initial temperature is the metal after I heated it up. And then the final temperature is the temperature of the water and the metal together. So remember, the metal is going to be really hot, and then you've got the water. You put the metal in the water, and the metal gets cooler, and the water gets warmer, and they kind of equalize there. That final temperature is that TF, the final temperature. It's the same for both of them. Okay, that's a good question. So for water, we're going to do the same thing. So the mass of the water is 150 grams. The specific heat of the water is 4.18, and that's joules over grams degrees Celsius. The final temperature of the water is 18.3, and the initial temperature of the water is 15 degrees Celsius. So our delta T is the final temperature minus the initial temperature. So 18.3 minus 15 gives us a change in temperature of 3.3. And there's a lot to keep track of here. All right, what are you eating right now?
I got hungry.
Got hungry? It's only been an hour.
I haven't had lunch.
Shh, I'm a bad parent for not feeding you. Okay, that's super loud. Can you just, it's like a movie theater, you know, you're not supposed to open the wrappers. Got to do it all before the movie starts. Okay, so let's start to plug everything into our equation here. So up at the top here, we have two sides. We have the water side, and then we have the metal side. Okay, so the metal side is losing heat energy, so it's going to be negative. So the water side is M is 150, that's the mass of the water, times the C value, which is 4.18, times the change in temperature, which is 3.3. And then we set that equal to the other side, so negative the mass of the metal, 15 grams, times C. We don't know the specific heat of metal, we're trying to find that, times its change in temperature, which is negative 56.7. All right, so at this point it's just simplifying. So the left side, the water side, you can just plug everything in and multiply it. I do not have my calculator handy. I just have the answer here. No, it's not in there. So I'm going to multiply these numbers here, and then I can multiply these numbers here to solve for C. So to get C by itself, once I multiply the left side, I'm just going to divide out the 15 and the 56.7, and you'll get C equals 2.43 joules over grams degrees Celsius. Okay? How was that? All of these are the same process. You're going to just kind of separate all of the information into like a table for water, table for metal, and then plug in all of your variables to the equation. So that's pretty much it. All right, if you're still having trouble with this, let me know. You should send me an email, and I can try to record another video or something, or tomorrow, if I have some extra time, we can go through some practice. Actually, tomorrow, during the chemistry half hour, I'm going to do a practice. I'm going to do some practice calculations for the lab. So they're very similar to this. So if you're still not understanding it, pop in tomorrow and we'll go through it. So actually 6 minutes over. I'm going to get paid overtime for doing this. So that's all I had for you guys today. I'll be back tomorrow for chemistry at 1:30. I don't know if you will be back tomorrow. And then I just want to remind you, on Friday, I have Dr. Sarah Perry coming in. She's a chemistry teacher at the University of Massachusetts. She's going to be popping in for an hour to answer your questions, and she's going to talk a little bit about what college chemistry is like, because I know a lot of you guys are going to be taking college chemistry. So if you have questions about like the difficulty, like what would be some good classes to take to prepare for it, what's the point of taking chemistry, I mean, just be honest with her. Ask any questions you have. I did email you a link where you can submit your questions in advance. But if you can't think of any, but you think of some during the Skype, she'll be able to see the chat. You guys can just ask your questions right in the chat, and that's it. So I hope you guys are all being safe, and I look forward to seeing you guys all tomorrow. Say goodbye.
Goodbye. I'll be here.